So I like to have some vocabulary. This is called your dividend. This is called your divisor. So the dividend is usually the bigger thing that's going to be divided. The divisor is what you're dividing by. And then what's the answer called to a division problem? Quotient, and then you've got your remainder. So if you set this up, we've done multiplication and factoring using the box. So you can also use the box to help you with division. You put your divisor down the side of the box because your divisor times your quotient should multiply together to reproduce your dividend, right? Because division is the inverse of multiplication. So if A times B gives you C, then going backwards, whichever one of these is your, let's say this is your divisor, this is your quotient, this is your dividend, right? Dividend divided by your divisor will give you back your quotient, right? So it's just a multiplication problem backwards. So if you're trying to create your dividend inside the box, right? So your dividend needs to go inside this box. So m squared is the first term of your dividend. So something times m has to give you m squared. This is going to be your quotient up here. So what's the first term of your quotient that's going to make this true? M. M times m is m squared. So now what is m times negative 8? I can fill in this bottom box, negative 8m. Are you with me so far? All right, so now I need to make the second term of my dividend show up. So what's the second term of my dividend? Negative 7m. How can I make between this box and this box? These two boxes have to add up to negative 7m's. So how many m's do I need to add in this box? Just one, right? Because I'm currently at negative 8 in the whole. So I need to add 1m so that when these two add together, I get my dividend that I want. So what's the final term of my quotient? What times m gives me m? So it's plus 1. So my quotient is m plus 1. 1 times m is m. 1 times negative 8 is negative 8. Now you figure out if you need a remainder. So if negative 8 was what showed up right here, you would be finished, but I need to get to negative 11. So what does my remainder have to be? Negative 3. So my quotient is m plus 1, and my remainder is negative 3. So you could write m plus 1 with a remainder of negative 3, or you could write m plus 1 plus negative 3 over m minus 8. Those mean the same thing, and I don't really care how you write your answer, because all we care about in rational functions is the m plus 1. That's going to be our asymptote line. I don't care how you write the remainder. It's important to know that there is a remainder or that it goes in evenly. Is your remainder 0, or is your remainder another number? So that might have seemed really challenging, but let's do a few more. It's kind of like solving a puzzle. And once you figure out how to set it up, it really is not so bad. So you put your n minus 6 down the side, and then we need to force this dividend to end up inside the box. So n squared goes first. What goes up top of your box then? What term needs to go here? This is going to be your quotient. So you put the n in your quotient because n times n is n squared. N times negative 6 is negative 6n. So on the diagonal, what do I need to add to get to negative 1n? What would I put in this box? Positive 5n. Those two add together to give you the negative 1n. Okay, so then you could do the top of the box. So that would have to be plus 5, so that 5 times n is 5n. 5 times negative 6 is negative 30, and I look to see if that matches. It doesn't, so I have a remainder of positive 1, right? Because negative 30 plus 1 would give me negative 29. So I have n plus 5 with a remainder of 1. So do you think you want to try one on your own now, or do you need to do one more together? Try 3. See where you get stuck on number 3, and then I'll put it up in just a minute. The next step from there, you put your n squared inside the box, and then n is the first term of your quotient. It won't always be, but these are set up for like learning. So n times n is n squared. Then you get 5n in the bottom box. So what did you put in the next box to get it to add up to 10n? Another 5n, right? Those two together add up to the 10n that you wanted. So then n plus 5 is the final answer. Let's see, 5 times 5 is 25, so this has a remainder of -7. So n plus 5 with a remainder of -7. So, and I was showing Emmy the synthetic division shortcut, which I don't want to not show it to you. I just think that if you mess part of it up, this is very clear to me. If you know how to multiply, you can divide. So synthetic division, and if you want to try synthetic division on number 4, just to see if you can do it, that's fine. It's just another strategy. So n plus 5, what you do is you take the opposite, or you take the 0. So the 0 would be -5. So you take -5 and you plug it into an array of numbers that are the coefficients of each of these terms. So 1, 10, and 18 in order. So once you have your array of numbers, you bring down the first. So the first number is just a 1. And then you multiply. -5 times 1 is -5. Add them together. You get 5. Multiply -25. Add them together. You get -7. So that's your remainder, that's your constant, and that's your x. X plus 5 with a remainder of -7. So if you want to try synthetic, if it feels like it would be a comfortable shortcut for you and you like shortcuts, great. If you just want one method that's going to work for everything, because this won't work for every single problem, only when you have a linear function like n plus 5, then you want to know the box method. So pick one of the methods to try example, for example 4. Then I'm going to skip to the back page and do the quadratic one with you, because then you could try the other two, and that's as much division as we're doing for today. We'll try it again tomorrow for some practice. So try example 4 if you haven't yet. K minus 1 goes down the side, k squared, k times k is k squared, -1k. So I need another -6k to add up to 7, -7k, right? So k minus 6 is the answer. And then +6, I need a remainder of 4 to get to 10. So k minus 6, remainder of 4. And if you tried it with synthetic, you would put a +1 outside for that k minus 1. You would put 1, -7, 10, bring down the 1. 1 times 1 is 1. There's your -6. 1 times -6. There's your remainder of 4. And there's your x minus 6. I don't know how synthetic works. It's a little bit of magic. But it is kind of cool. It's a way to check your answer too. If you're like, all right, I'm going to do synthetic and do the box, and then I'll make sure that I got the same answer, just to double check. All right, so I want to show you one that synthetic will not work on, and then you can just try example G and H up above. But take a look at P of X, because this has 3 terms. Sorry, it printed kind of small, I guess. Whoops. It has 3 terms in your divisor. And so you're just going to have 3 terms down the side of your box. You just make your box a little bit bigger. And the diagonals get a little bit bigger. So there might be one problem like this that shows up. So I do want you to know how to do a division using a trinomial. I never know how many boxes to put going across, so I might add on a box. But I know that down the side is going to be x squared plus 2x plus 1. So you have a 3-term divisor. And you do it the same exact way. So you're going to put x cubed in the top left, and you're going to put x up here, because x times x squared is x cubed. But then you just have to fill in these 2 boxes as you go down. So you'd have 2x squared and +1x. And then you've got a couple different boxes to work with. The only one you want to focus on is the next highest term. So the x squareds are going to be these two boxes, and then the x term is going to be these three boxes in a minute. So we're just going to work on x squared. How many x squareds do I need? Negative 2x squared. So I need to put negative 4x squared in this box so that when I add them together, they add up to what I want. And then I'm just going to put a negative 4 up here because I already have x squared. So actually, this is my whole quotient, because once you get to a constant, you can't go any further than a constant term. We're just going to work on what our remainder is now, or if there is a remainder. So I multiply these two bottom boxes, negative 8x, negative 4. And then if you look across, this, and this is going to be your x term. And then the other two boxes, I have another color. So this box and this box are going to be your constant term. So I'm looking for a two-part remainder. So let's see, I have a total of negative 7x's, and I need to get to positive 1x's, right? So I need to add 8x. So 8x is part of my remainder, right? Does that add up to x? And then I need to add up to negative 9. So the other part of my remainder is negative 5. So I have a remainder of 8x minus 5. And like I said, I don't really care about the remainder, just that there is one. So x minus 4 would be your asymptote when we start talking about asymptotes. All right, you're going to try two more, and then I'll show you how to put those graphs in your calculator. So try G and H using one of the methods. Be careful on H. When you get to H, you may want to rewrite it x cubed plus 0x squared minus 2x plus 9, because that 0x squared needs to be inside your dividend. So see how you can do on those two. I'll give you a couple minutes to try them. When you're finished with G of H, that way you can look up and check it. Okay, so the second one, you put your x plus 2 down the side. And so let's see, I need to get x cubed here. So I'm going to have a quadratic x squared, 2x squared. I need to get 0x squared. So that's why it's important to recognize there are 0 of them, because 0 is a number. So I've got to get rid of these 2x squared. So I'm going to subtract 2x squared in this other box so that I end up with net of 0. So then minus 2x is the next term of your quotient. So you've got negative 4x now. Now you go about finding your how many x's you need. I need negative 2x's, so I have to add 2x's then. So plus 2 would be your constant. And then let's see, 4, the remainder would be positive 5, right? I should have made one of these come out to a remainder of 0, but eventually we'll have a remainder just come out to 0, because then they went in evenly, right? So how does it feel like maybe by tomorrow, if we did some more practice, you could get the hang of polynomial division before we jump into graphing with some polynomial division? All right, so what I'd like you to take the next little bit with, there are 8 graphs. So by the end of the unit, you'll know all the steps to graph these by hand. That's what's going to go on your note card for the first couple quizzes. But for now, I just want you to start recognizing what some of these rational functions look like, because they look very different. Some of them are just two elbows. Some of them have like a parabola with a couple elbows. So I'll just do the first one with you to make sure you know how to plug it in your y equals menu. So grab a graphing calculator, clear out your y equals menu. Anyone else need a calculator?